Okay, up next, what if we wanted to insert a new item? Now, we've inserted before using the append method and by concatenating, but in all those cases, we simply added it to the very end of the array, right? The item always went at the next index value. What if we wanted to insert a new item at a specific point in the array? Again, here, we're going to use another method. And again, let's ignore what method means right now. Just follow along and type with me. One day we'll get to methods and you'll understand. So let's add a comment. We'll say insert using indexes. So as the comment says, again, we're going to use an index value to put something in an arbitrary position in the array. As always, we start by typing out the name of the array we want to work with. And remember to use methods. You don't have to internalize this because we'll get to it at some point. But to use a method here to insert, we always put a period after the name of the array or a full stop. And like we started typing append before, we're going to type insert. And again, Xcode autocompletes. We're going to hit enter. You'll notice that the method here reads insert new element at, and then takes an integer. And basically we're saying we want to insert some new element at an index position. Let's add the string watch TV at index 2. Now, if you look at the results pane, you'll see that it's watch treehouse content, buy groceries, and watch TV. If I type out the array before we actually carry out this insert operation, you'll notice it's watch treehouse content, buy groceries, and respond to emails. The neat thing here is that we're not getting rid of respond to emails because if you look below, you'll notice that it goes from buy groceries to watch TV and then back to respond emails, and then the rest of the array is just like before. When you use this method to insert an item into an array at a specific index value, Swift and the compiler is doing some stuff in the back. So what's happening here is we insert watch TV at position 2, which is the third element. But because there are more elements in the array, we now have to update the index values of these new positions that these values occupy. So respond emails, which was in position or had an index value of 0, 1, 2, now has an index value of 0, 1, 2, 3. Essentially, every item after that index position that you inserted your new item at has their index values increased by 1. So for example, what was in position 2 is now in position 3, what was in position 3 is now in position 4, and so on. To finish up adding and reading, let's try and remove items. Let me get rid of that. There we go. And I'll say removing items from arrays. Like inserting, again, we're going to use a method to do this. So start with the name of the array, period, and then remove. The remove method takes an index value. So again, rather than saying we want to remove this particular string literal, we say we want to remove what is at position and then provide that position. So if I want to get rid of watch TV, which I just added, I'll say position 2. And now if I list out the array before and after, you'll see that we go from watch treehouse content, buy groceries to watch TV, which is just like it was after the insert operation, to watch treehouse content, buy groceries, and then respond to emails. So it's important to know that remove, like insert, involves updating the entire array because we're actually pulling out watch TV from the entire array, which means that the flip side of what we did earlier happens. So basically, respond to emails was at position 0, 1, 2, 3, and now it's at position 0, 1, 2. So every item after the index value that we removed has its index decreased by 1. So basically, respond to emails goes back to 2, pick up dry cleaning goes back to 3 from 4, and so on. So when you remove something, it's important to note that that position in the array isn't empty. We shift everything back so that the array always has a certain number of spots occupied. There are no empty spaces in an array. All this work we do on an array when we insert or remove means that the number of items in the array are constantly changing. Now, if our array is small, that's okay, no big deal. We'll just shift a couple items in their index spots. But imagine you had a database of millions of items, right, in an array. If you remove or insert an item into one of these large arrays, then all the rest of the million items, million minus one, have to be shifted over. And that takes a long time. So it's not something that we should worry about now, but an interesting thing that you should be aware of, that the larger the array, the more expensive these operations are. It just takes forever. To round this up, what if we wanted to know what's actually in an array? After we've done inserts and removes and modifies, how do we know, or how do we keep track of how many items are in the array? Luckily, there's another property that we can use. Again, we don't know what properties are, no big deal. But all you have to do is type to do, type the name of the array, a period, and then we'll say count. And over here, you'll see that this to-do array contains 6 items. It's important to note that the number of items in an array, so here we have 6 items, is always one value higher than the maximum index value. So, and this is because the first element is always at index position 0. So, if you do to-do 0, you'll get the first element in the array, which is watch treehouse content. And if you do to-do 5, you'll get the last element, which is order books online. So if you want to get the last element in the array, one way you can do this, we'll cover other ways later, but one way you can do this is always querying this count value. So we know it's 6 here, and then doing count minus 1. Now, because count is always 1 greater than the maximum index value in the array, what happens if we do to-do and then use the value returned by count, so 6? When you do this, you should crash. You get an error here, and you'll see at the bottom it says index out of range. So basically, index values are important, and if you try and access an index value or a position that doesn't exist, you're basically poking at memory in the computer that is unoccupied, and your computer or your program will crash. So never exceed the bounds of the array. Basically, never query for more than the max index value. So let me add a comment in here. We'll say to do 6, crash, do not use an index value that equals number of items in the array. There you have it. Arrays are very flexible data structures that allows us to work with multiple values. We'll certainly see more of arrays in the future, but for now, this is a great place to start. Before we move on to looking at another data structure, let's get in some practice with a code challenge. I want to reiterate before you finish this video that we encountered a new concept here that I called a method. Don't worry about knowing what this means exactly. Methods are a totally separate topic on their own, and we'll spend a lot of time going over it. For now, in the code challenges, if I ask you to use a method to manipulate an array in any way, I will provide the exact syntax for the method in the instructions. Good luck!